Today we are going to discuss a topic, frequency distribution for quantitative data, frequency distribution with unequal class width. Already we are aware of which type of classifications do you know. Apart from that, today we are going to discuss frequency distribution for quantitative data. So, quantitative data means what? It is a number. That quantity should be given the certain information. Okay. Now, frequency distribution for quantitative data. Here we have two types of frequency distribution for quantitative data. One is case 1, that is case 1 if the data set consists repeated values. For quantitative data having few values which are repeating continuously within the data sets can be expressed with a discrete frequency distribution. In this case, to summarize such data, we can arrange values in ascending order and count their frequencies by using tally bars. Simply the data set consists of repeated values. Just we have to identify what is the use of tally marks. We would like to find out the frequency values of the data set. That is the case 1. Now, coming to case 2, if the data set consists value without more repetitions. In this case, to construct a frequency distribution, we use class intervals. To construct such distribution, we need to following terminology. So, in that case, we can use class intervals. So, what do you mean by class interval? So, class interval, how to construct the frequency? You know how to construct the frequency distribution. Using that frequency distribution, we can put appropriate values in the given class intervals. For this point of view, we use this class interval concept. To construct a frequency distribution, the entire range of data can be divided into various subranges. Each subrange is known as class. Each class can be represented by two values. They are lower limit and upper limit. So, once again repeat the statement, each subrange is known as a class. Each class can be represented by two values. They are lower limit and upper limit. So, what do you mean by lower limit? What do you mean by upper limit? Lower limit represents the smallest possible value of the class. So, lower limit means it represents the smallest possible value of the class. Upper limit, it represents the largest possible value of the class. So, how you identify the difference? These are the basic difference between the upper limit and lower limit. Lower limit takes a smaller value, upper limit takes a larger value. The length of the class is called class interval. Now, come to the main topic is class interval. So, class interval means it defines like that the length of the class is called the class interval. It can be determined by evaluating the difference between lower limit and upper limit. The number of observations in each class is called class frequency. So, here the class interval means the difference between the limits. Which two limits? Upper limit and lower limit. For example, in the following frequency distribution 10 to 20, 20 to 30, 30 to 40 and so on. Here 10 to 20, 10 is treated as a lower limit and 20 is treated as a upper limit. That means, here 10 to 20, 20 to 30, 30 to 40 and so on are called classes. In these classes, already you are aware of upper limit and what do you mean by lower limit? What is upper limit? You should identify it in this example. In this frequency distribution, 10 is 10, 20, 30, 30, 40, 50 and 50. These are called lower limit values. That means are called lower limit of the first, second, third classes etc. respectively. Now, one more limit already you know, that is upper limit. 20, 30, 40 are called upper limit of the first, second, third and fourth and so on respectively. The difference between the upper limit and the lower limit of the class are called the length of the class interval. Example, 20 minus 20 is upper limit in the first class, 20 minus 10 that is 10, 30 minus 20, 10 and so on. So, now you have observed in this table class interval is in the first column and frequency is in the second column. First column is represented by class intervals. This class interval consisting lower limit and upper limit of the table. So, if I check the first column, first row, class interval is what? 10. Class interval designated as a first row is designated as a class interval and frequency. Here under that 10 to 20 class interval, in that 10 is treated as a lower limit and 20 is treated as a upper limit. What is the corresponding frequency? Its corresponding frequency is 8. That means, how to get the frequency? By making use of that repeated numbers or individual numbers, that is treated as a repeated, that is a attribute. That attribute is put in a frequency form. So, those frequencies represented, that numbers are represented in terms of frequencies. Okay. So, 10 to 28, 20 to 30 12 numbers, and 30 to 40 15, 40 to 50 8, 50 to 66, 60 to 72. So, this is the class interval representation. Now, here these class intervals are two types of class intervals. First one is inclusive class intervals and second one is exclusive class intervals. Class interval means already you know the definition of what you mean by class interval. First one is inclusive class intervals. In a frequency distribution, if the upper limit of the class included in the same class, then the class intervals are called inclusive class intervals. For example, in the following frequency distribution, the upper limit of the first class 9 included in the same class. 19 is the upper limit of the second class included in the second class and so on. For example, your frequency value is 8, that is included in the first interval. If your value is 9, 9 is also included in the first class. If your value is 29, that is included in the third class interval 20 to 9. This type of classes are known as inclusive class values, inclusive class intervals. So, 0 to 9, so class interval. So, that means there is no continuity between the two consecutive limits, which limits are known as upper limit of the first class interval and lower limit of the second class interval is not same. This type of class intervals are known as inclusive class interval. There is no continuity between the class intervals. So, that is a class interval, that is you have to identify this type of class intervals are known as inclusive class intervals. Now, coming to second one, exclusive class intervals. Exclusive class intervals. In a frequency distribution, if the upper limit of the class excluded from the class, then the class intervals are known as exclusive class intervals. Your earlier one is different, this is that means there is a two consecutive limits, upper limit and lower limit of two consecutive limits are same, continuous manner. That type of class intervals are known as exclusive classes. In a frequency distribution, if the upper limit of the class excluded from the class, then the class interval is known as exclusive class interval. For example, in the following frequency distribution, in the first class interval 0 to 10, 10 is excluded from the first class. It included in the second class, that is 10 to 20 class interval. Similar from second class 20 excluded and it included in the third class, that is 20 to 30 and so on like this. So, class intervals are 0 to 10, 10 to 20, 20 to 30, 30 to 40. Your frequencies are 8, 12, 13, 6. So, that means, so exclusive class interval means if it is the same value is occur, that is included in the second class interval. If it is a 10 is, for example, here 30 is repeated, 30 is your value, that 30 is excluded in 30 to 40 class interval. This is a way of construct the class intervals. Okay. Now, we are studying about two types of class intervals. One is inclusive class interval and second one is exclusive class interval. Now, we have various forms of frequency distributions. This is also very important topic. So, we have various forms of frequency distribution. One is open end frequency distribution, frequency distribution with unequal class width, cumulative frequency distribution, relative frequency distribution. These are the 4 categories of frequency distributions. While talking about class intervals, after knowing the class intervals, we are talking about different types of forms of frequency distributions. Now, we will discuss one by one. First one is open end frequency distribution. Open end frequency distribution. So, open end frequency distribution, in this open end frequency distribution, one which has at least one of its ends open, either the lower limit of the first class or upper limit of the last class, or both are not specified. Both are not specified. The word below or less than or and above or more than are used in that case. In the former, the value extends to minus infinity and the latter it is followed by plus infinity. Example for open end frequency distribution is, if a lower limit of the class is unknown, either upper limit of the class is unknown, that means if it is minus infinity to plus infinity, lower limit is value is unknown and upper limit value is unknown, that is called as open end frequency distribution. Example of such frequency distribution is given in the following table: class interval and frequency. First column is represented by class interval and second column is represented by frequency. So, my first class interval is less than 10. Less than 10 means, what is the meaning of less than 10? It is take numbers, positive numbers or negative numbers, whether it is real numbers, whether it is integers. If your values are non-negative values, real numbers start with minus infinity. That means less than 10 means minus infinity to 10. This is one open interval. Open interval is lower limit is unknown, upper limit is 10. This type of class intervals are known as open end frequency distributions. Open end frequency distribution. Less than 10, 8, 10 to 20, 12, 20 to 30, 13, 30 to 40, 6. Now, class intervals frequency. Now, one more example for earlier one is lower limit is unknown. Now, open end frequency distribution. Now, one more example we are taking here. Our class first column is designated as a class interval, second column is represented by frequency. In that 0 to 10, lower limit is 0, upper limit is 10, 10 to 20, 10 is lower limit, upper limit is 20, 20 to 30 and more than 40. More than 40 means where we end the numbers we do not know. That is why this is end, open end frequency distribution. If your class intervals are like this, one is either less, either lower limit is less than and upper limit is more than. This type of frequency distributions are known as open ends frequency distributions. Now, coming to second one, a frequency distribution with unequal class width. The word it seems to be tells about unequal class width. The classes of a frequency distribution may or may not be equal width. A frequency distribution with unequal class width is reproduce the table. That means the frequency is having, the difference is having class interval mid values are vary from different values, not uniformity, not maintain the uniformity. That type of such type of class intervals are known as unequal class widths. Now, coming to third one is relative frequency distribution. Relative frequency distribution, we have to use one formula for estimating the relative frequency distribution. For a quantitative data, a relative frequency distribution identifies the proportion of the values that fall into the each class, that is class frequency. Sometimes that class interval, that frequency is not tells accuracy result, in that how much ratio of values fall under particular limit. In that case, earlier two methods are not applicable, earlier two frequency distributions are not used. In that case, we can use only relative frequency distribution. So, how to find the relative frequency distribution? That is class relative frequency. We have to estimate the class relative frequency. So, class relative frequency is obtained by class frequency by total number of values. So, what is the formula for using getting of relative frequency? class relative frequency is equal to class frequency by total number of values. Then coming to next one is fourth one, cumulative frequency distribution. Example, for cumulative frequency distribution, if you take the class attendance, that is the cumulative only day 1 to we have count and end with the end of the semester, that means carry forward to every day. Attendance will count cumulative manner. You have heard this word cumulative frequency. Now we are talking about cumulative frequency distribution. In a cumulative frequency distribution, the cumulative frequencies are calculated by adding successive class frequencies. The cumulative frequency of a given class is equal to the total number of frequencies that of its preceding classes, and the class frequency for with cumulative frequency is calculated. If the cumulative frequency is of less than type, will represent the total frequency of all the less than and equal to the class value which is related. So, here two types, less than cumulative frequency and more than cumulative frequency. If we are talking about cumulative distribution, cumulative frequency distribution, less than cumulative classes and more than cumulative classes. So, if I talk more than cumulative type, if it is more than type, it will represent the total frequency of classes more than and equal to the class value with it relates. Now, I am taking the example for in that case, number of defective produced, number of days. Here in the last two columns are represented by less than cumulative frequency and greater than cumulative frequency. Less than and greater than cumulative frequency. So, number of defective produced 0, 1, 2, 3, 4, 5 up to 5. Number of days 18, 5, 3, 2, 1, 1. That means, what is the total number if adding the total number of days? How many number of days we have totally? 30 number of days. If I calculate the less than cumulative frequency which is represented by LCF. So, first days, how many days for first row? 18, that is the first frequency. 18 plus second row frequency, second row frequency is what? 5, 18 plus 5, 23. Again 23 plus third row frequency values. What is the third row frequency value? 3. So, already we have 23 plus 3 is equal to 26. Now, coming to fourth row, our frequency value is 2 days and already we got less than cumulative frequency is 26. 26 plus 2 is equal to 28 and so on like this. Finally, we got 29 plus 1, it is a 30. The 30 is equal to the last number is equal to total number of days. This is known as a less than cumulative calculation part, less than cumulative frequency. How to calculate the less than cumulative frequency? Just now I give an example here. Now, we are talking about greater than cumulative frequency, GCF. Now, already we know that total frequency. What is the total frequency? How many number of days? Total number of days is equal to 30, which we can write in the first row of the given table, which is designated as a last column. 30 minus previous, that corresponding number of days. How many number of days in 0 interval? 18. 30 minus 80 is your greater cumulative frequency. 30 minus 18 is 12. Next 12 minus its second day, number of defective produced in 5 days. How many number of produced here? 5. Number of days are 5 here. 30 minus 18 is equal to 12. 12 minus 5, 7. 7 minus 3 is 4. 4 minus 2 is equal to 2. 2 minus 1 is equal to 1. Then it is known as a how to calculate it represented. How to calculate the greater than cumulative frequency. This is a way of computing the greater than cumulative frequency. Less than cumulative frequency and greater than cumulative frequency. Okay. So, these are the how to calculate the less than, how to calculate the greater than cumulative frequency. So, this is a way of identifying how to calculate the less than and greater than cumulative frequency. Now, where already I said this, LCF means less than cumulative frequency and GCF means greater than cumulative frequency. The above table indicates quickly the number of people drawing the less than or more than a particular value. It may be noted that the cumulative frequencies are corresponding to the class limits or class boundaries. The less than cumulative frequency and more than cumulative frequencies are corresponding to the lower limits or lower boundaries of the classes. So this is the quickly response. How many people are below that average salary? Below salaries we can easily identify by making use of less than or greater than cumulative frequency concept. Now, if I talk the less than cumulative frequency distribution, upper limit and the less than cumulative frequency distribution. So, this basically used for how many students are falling less than 20 marks, less than 40 marks. If you can calculate the 100 marks for external examination, after that how many students are less than 90, less than 70. If you want to calculate, if you can't use the interpretation, how many students are above average, how many students are below average. In that case, we can use cumulative frequency distribution, upper limit less than 10 marks. How many students are fall under this? Like this, we can use the example. That means, in that example, less than cumulative frequencies are used for less than 10, less than 20, less than 30, less than 40 and so on. So, in that case, we can use the less than cumulative frequency like this 8. How many students are, how many numbers are, how many persons are comes under less than 10? 8. Less than 20, 20. Less than 30, 33. Less than 40, 39. This is a way of representing the less than cumulative frequency. Now, we are talking about greater than cumulative frequency distribution. Our limit is greater than 0, greater than 10, greater than 20, greater than 30. Greater than cumulative frequency 39, greater than 10 31, greater than 20 19, greater than 30 6. So, this is the representation less than and greater than cumulative frequency distribution examples. Now, we are talking about this again this greater than cumulative frequency distribution and these frequency distributions. What is the use of these frequency distributions? Generally, the applications of frequency distributions are we can identify the raw data into appropriate manner. So, 4 types, and under that we can apply different manners, that cumulative distribution, relative frequency distribution, and these are the 4 categories: open end class frequency distribution with unequal class width, cumulative frequency distribution and relative frequency distribution. These are the various forms of the frequency distribution. By making use of this frequency distribution, we can arrange the data into appropriate manner. So, using these frequency distributions, so what are the application, what are the merits, what is the use of this frequency distribution? We can use these frequency distributions to evaluate the mean values, measure of central tendency, measure of dispersion. It is based on these frequency distributions. So, what is the use of this frequency distribution while you measuring the central tendency values and class intervals, measure of central tendency and measure of dispersion? So, especially your limits are class intervals limits are open end type of limits, which measures of central tendency distribution we can use. So, already you are aware of these frequency distributions. These frequency distributions, so any raw data we can convert it into frequency distribution manner by making use of using the tally marks. Tally marks means what? Particular interval we can write that, arrange the data into frequency distribution. Open end frequency distributions, frequency distribution with unequal class interval, cumulative frequency distribution and relative frequency distributions. So, basically, 4 most important concept is the data set consisting of repeated values, or if it is the class intervals are play the vital role while evaluating the range and mean, median, mode, measure it is measure of central tendency, whether it is measure of dispersion. So, lower limit and upper two consecutive limits are continuous. So, using these class intervals and frequency distribution, we should evaluate the mid values. Using these mid values, we can identify the whether it is mean value, whether it is median value, whether it is standard deviation, mode, what are the values we are identifying. That is why, so construction of frequency distribution is very, very important. Construction of frequency distribution is very, very important. Now, we can conclude this session. So, what I am trying to say here in this chapter, so you are aware of this, what do you mean by frequency distribution? What are the forms of frequency distributions? How to construct the frequency distribution? These are the four most important key points. Using these frequency distributions, we are go for further statistical analysis. Using these tables, frequency tables, we should interpret the data, we can evaluate the data. That is the main theme of this class intervals and frequency distributions.